Okay, day 8 notes. Objective to write 2 column proofs. So we're going to learn a new rule today. Okay, so we're going to do a 2 column proof. Let me get this back to a different view here. Okay, so we have, it says angle W is congruent to angle Y. So we mark that. It also says CY is congruent to WC. I would call this CW instead. Just keep the order the same. And then we can mark this angle congruent because of vertical angles. And now we just go into our proof. Okay, so we go with our given angles. And we say CY is congruent to CW. And those are both given. Then we add our new one. So remember, I'm going to start at arc 1 and go down highway 1. And start down here at arc 1 and go down up highway 1. So I'm going to say angle WCR is congruent to angle YCM. And that's the definition of vertical angles. Now once I have that, I can prove ASA. So I can prove the triangle WCR is congruent to triangle YCM by ASA. If you need to pause, go ahead and hit pause. Okay, example 2. A is the midpoint of CR. So at that point, we know this and this are equal. It also says CAS is equal to RAS. We know they're going to be 90, but we just have to mark them congruent. And we know this is congruent to itself. So now we go on. Sorry for the goofy line. Reason. So we say A is the midpoint of CR. And angle CAS is congruent to angle RAS. And these are both given. Okay, so now we just fill in what we marked. So we said that CA is congruent to RA, and that's the definition of midpoint. Horribly, I'm sorry. And then we say that AS is congruent to itself, and that's our reflexive property. And then what do we have? We have SAS. So we can now say the triangle CAS is congruent to triangle RAS by SAS. Now we're going to add one more step, cpctc, which stands for corresponding parts of congruent triangles are congruent. So we use this after we prove triangles are congruent to prove other parts are congruent. So this is going to be the same as we've been doing. Steps 1 through 5 are exactly the same we've been doing. And then step 6 is added on for an extra step. So LEI, KEI. So we know this angle here is congruent to this angle. LE is congruent to KE. And we know this is congruent by the reflexive property. So we're going to do the same thing we've been doing. We're going to start off by saying angle LE is congruent to angle KEI, and that LE is congruent to segment KE. And these are both given. Next, we're going to mark IE congruent to itself with the reflexive property. Once we do that, we can say the two triangles are congruent by SAS. So I will say triangle LEI is congruent to triangle KEI by SAS. Now, that is not our goal, though. Notice our goal is to prove that L and K are the same. Well, we can do that now. Angle L is congruent to angle K because corresponding parts of congruent triangles are congruent. Let me try that again. A little sloppy there. Corresponding parts of congruent triangles are congruent. So once we prove here the triangles are congruent, we can prove any part. Okay, example 4. S is congruent to K. I is the midpoint of SK, meaning these are equal. And we have vertical angles here. So we get on with our proof. Angle S is congruent to angle K, and I is the midpoint of SK. Given. So what do we mark? Well, we marked SI is congruent to KI, and that's due to the definition of midpoint. Then we said that angle SIT is congruent to angle, start the same arc mark, 1, so that's K, come in highway 1 to I, N, for my angle symbol. SIT is congruent to kin, and that's definition of vertical angles. Or vertical angles are equal, either way. Now we can say that at triangle SIT is congruent to triangle KIN by angle side angle. Got a little backwards there. And now, because of that, we can say line segment or side ST is congruent to segment NK by cpctc. Okay, example 5. BE is congruent to BA. ER is congruent to AR. Obviously, the side is congruent to itself. We're just going to do the same thing. So BE is congruent to BA, and ER is congruent to AR. Given. We say that BR is congruent to itself by the reflexive property. Once we have that, we can say that triangle ERB is congruent to triangle ARB by side, side, side. Once we've proven them congruent, we can say that angle ERB is congruent to angle ARB by cpctc. And there you go. That's the end of the notes.